Hi, good morning. So, presentation on busbar mounting and jointing arrangements. So, by Madutech. Welcome you all. So, there is a lot of information we'll go to come share here. So, one of our technical general manager, Mr. H.S. Kumar, is having a 40 years of vast experience in the panel board industry. He has shared his experience to our R&D department team. So, it's good in I impressed so I would like to share this to all the team form of panel board industry people. So kindly do watch till the end. You will get a lot of benefit. So what is the bus bar? Do we need it? So this is a doubt, basic doubt people will be having. Yes, bus bar we need. It's a bus bar is a conductor. So to transport the current from one place to other place to distribute the current, we need a bus bar system. So to handle the heavy loads, this is the looks like bus bars. So how it will be arranged inside the bus bar panels. So this is the bus bar. So here three-phase four-wire system, three-phase three-wire system, or single-phase system. For all these things, we need the bus bars to carry the current. How does the new bus bars looks like? So if you see here, so this is the new bus bar which during procurement would have seen all the bus bars. So we'll see the surface, different sizes according to requirement we'll procure. So this is the bus bar which looks like this. So bus bars is available different types. So we can select according to our requirement. It will be on the C section type, so C channel and L channel and a round shape and a rectangular shape. So it depends on our requirement. We can choose the conductor type, what type of things we require. We make gallium, copper, both the things. Normally in Indian industry, we go for maximum aluminum conductors. So aluminum also will get different sizes and different types of bus bars. So this is also bar which normally the wood industry people will use. So this is a very good conductor and it's a modular piece. This is a specialized customized design which only few people will use this type of arrangement bus bars. So this is also a good conductor. This is a type of bus bar which is available in the market. Again, it's a special design. So based on the panel design and people's requirement, so we can go for this type of arrangements also. This is a modular bus bar structure. So here we need not to drill it. So just we need to insert the nuts inside, and we can connect the jointing. We can able to take without any drilling on the main bus bar. Only the interconnection bus bars has to be drilled and taken through this the slots which is provided on all the bus bars. So any direction, top, side, and bottom directions, all the directions we can able to connect the interconnections. This is also very good thing. And comes to the next. What is the important in the bus bar surfaces? What we have to look here. So when while bus bar looks like it's a smooth finish, our naked eye we can't able to identify so how the bus bars looks like, whether it's surface is flat or waviness is there. All these things we can't able to see. If you go and see the nanoscopic meter, through that you can able to identify so what is the bus bar level, how it is formed, whether it is good conductor or whether we can use the in the electrical systems. All these things we can able to see the surface level. So that is very important. If you see here, if you see microscopic, if you see this is the waviness you will find on the bus bar surface. If you go for nanoscopic observation, so this is the way. So this is not the way we need to use the bus bars. So because during joints we may not get proper joints there, so we may lose a lot of millivolts there, drop the millivolts, then it is not a good jointing thing. So this is a representation of the bus on the surface of the bus bar, how it looks like. So it's like mountains, uh, mini mountains formed on the bus surface. So this type of surface is there. It is very danger. We can't use a lot of bus bars we would have purchased, and the current carrying may not be up to the mark, whatever the calculation what we have done. So it may not perform that much current rating. So hence the bus bar surface is very important for us to choose the right bus bars. So if the mountains type surface is not proper, so how the current will flowing will take place. So this is a top one conductor, and below is another conductor which is a joint place. So this is the joining place. So you can see wherever touching that tip points are there, mountain tip points, there only current is flowing. So balance places current only tips is a current carrying is taking. So this is not a right practice to do in the panel board industry. See, this is a flat surface which we don't have any mountain surfaces on this flat bus bars. So if you see like this, there is a distribution evenly is happening on the joint. So the current carrying capacity also will increase. So that so whatever calculations we have done for sizing of the bus bar, all these things will be ensured. This type of surfaces if you go for. So this is the improved results after doing some buffing work, all these things we can able to achieve this result. If you see here, so what is the result before buffing of the bus bar and after buffing of the bus bars? So this is the without buffing of the thing. If you pass 100 amps current, in that you will find the 14.1 is the millivolt drop. So in the joint you will find. After buffing, the surface you have made smooth and it is very flat surface you have made after all the buffing to work. So current also is increasing 118 amps we can able to give. If you give, so millivolt drop is only 9.7 volts. So see 14.1 to 9.7, it is dropping the millivolt, and it is carrying current also is increasing by 18 amps. So every can see. So this is the without buffing results. So after buffing, this is the results. So it purely indicates that the surface should be neat and clean, and the surface should be level, so that the current carrying also will increase. How to measure the bus bar joints heating effects and all. So this is one of the sticker which is available. It's a thermal based sticker. What is the feature? See, if you see 30 degrees Celsius on the connecting joint, so this will be indicated as a red. Then 35 degree it will go to here. So both the 30 and 35 both will be red. The balance will be gray color. So it will go increasing according to the temperature uh, available on the bus bar surface and the joint surface wherever we fix this sticker. So this is a reversible also. After that, it may reach 60 degrees Celsius. Then the load is reduced, or your ambient is came down. So based on that, your air circulation is improved inside the panel. So then the temperature may come down. So during that time, again it will reverse. It will come. So this is the color will change. This is the one-time sticker. So we will not waste this one. It's a bit costly one. So wherever the important giants, data centers, so all these places, so we can use these type of stickers so that it's clearly indicate that there is a giant problem. So immediately we can attend to it, and we can avoid any major breakdowns future. So this type of sticker also is available. So this is not irreversible. It's one time use. Price also is economical. So once it goes temperature, then it will not come back. So this sticker we need to replace again once it is goes beyond our temperature limits. So again, it will not be reusable, this sticker. So this type of also available in the market. So we can go for fixing the critical joints, critical loads wherever is there we feel. So that type of joints we can use these type of things. So normally in the panel board industry, we use this is the insulators and supporting systems for the bus bars we'll use. This is the conical supports. This is the slotted SMC, and this is the G047. It's a modular design, which this type of insulators we'll use according to our design panel designs. So this is one type of mounting arrangements using slotted SMC or FRP. So this is a RYB neutral. So this type of mounting arrangements also we can able to do. So if you see the bus bar arrangements, how it looks like on the top view of the panel. So it looks like this. So this is the enclosure part. If you see, this is the bus bar running all the way here. So in between, this is the bus bar supports. So according to K rating, so we need to space these supports, which is the distance we need to place. So based on the K rating design, we need to choose this distance between the supports. This is one arrangements which Modutech normally will use. So this is a G047. So this black one is the insulator. Top of that it's a MS support, bottom and top, with in between full threaded rod, stainless steel we are using here. And important while designing the bus bar arrangements, we need to ensure. So this is the two phases. This is one phase. This is another phase. So between the phases, these three runs of the bus bar, between bus bars runs, the distance we can maintain 10 mm minimum. So maximum we can go. So based on our place availability. So if you increase here, we will not going to change major results in the bus bar current carrying or short circuit. We have to ensure always between phase to phase, the distance is matters designing. So we need to ensure this is the design. We need to keep distance between phases as much as possible. We need to keep more distance between the phases. So that is to reduce the mechanical force during short circuit, whichever comes on the bus bar systems. So it will be, if you reduce, the impact will be more. If you increase, the impact will be less. So that enclosure strength and the support strength and all will be taken care while placing this adequate distance between phases. So this is the formula we can use during calculation. So what is the distance we need to keep? So during short circuit, so how it will impact on the bus bar system? So you can see here, this is the impact. The forces, ripple forces are coming during the short circuit. So it looks like this. To increase the distance between the phases, this type of thing can out. So this is a mechanical force developed during short circuit. So this is the graph which represents the force which is coming from there, where it withstands. So all these things we can able to see here. If you increase more also, so there is a stand still it is coming here, you can see. So then increasing more also will not going to support. So as per whatever the required, that much only we need to increase between phases distance. Here also the between phases what we are showing. This is also graph represents, and the current carrying also will increase if you make the distance sufficient distance. So mechanical force developed during short circuit. So this is the between A center of the bus bar and here B center of the bus bar. This is the S. So this is the distance we need to maintain. So based on our short circuit levels, we can maintain this distance. So based on our bus bar arrangements, the current carrying also we can improve using the same bus bars. So if you arrange side by side one bus bars vertically, so this is a 100% we can able to take the current from this type of arrangements. If you make the same arrangements, only the between two runs you are giving some gap. For example, 30 mm you are giving the gap, so that the heat dissipation will take place and the same bus bar can able to deliver 118%. So that means 18% increase only changing the system, the bus bar arrangement between these two. Again, if you go for round type, it's a circular bus bars, so you can go up to 125%. The same square mm 125%, 100 to 125%. That means 25% increase in the current carrying capacity with the same material, only the different type of materials we are using here. So other thing, so if you go for this type of arrangements, it's a rectangular arrangements. So the same 4 bus bars, whatever is there, if you go for rectangular type, the square mm is the same. The current carrying is increasing from 100 to 128%. That means 28% is increasing here. So here there is no gap between. So hence it's on 128%. If you go C type, C channel, which we have shown in the bus bar type of bus bars. So that type of bus bar, if you go, so it is going 151%. So almost 51% increase in the current carrying capacity of the same square mm of the bus bars. So if you go for 2-tier arrangements, so this is another arrangement. So 2-tier, same 4 bus bars instead of side wide. If you go for one above the one, so these arrangements will increase to 57% of the current carrying. So from 100 to 57, it's almost 57%. If you go these type of arrangements, so these arrangements goes to 185%. That means 85% more than 100%. So 185% will go to increase on the current carrying capacity only because of the arrangement how we are making in the bus bars. So influence of bus bar mounting arrangements on the overall current rating. So this is the S between center face of the bus bar and another face, center face of the bus bars. So between distance between face, that is equal to S. So this is S. 3 into A, that is the derating factor applicable is 0.82. If you make 4 into A, that is 0.89. 5 into A, 0.95. So like that it goes on increasing up to 1 it can go. So this is the difference. If you make this S bigger, so that the current carrying derating factor also slowly it is decreasing. So 0.82 it's come to almost 100%. This is another type of chart which you can see here. This is the bare painted surface, the bus bars. This is the bare conductor. So between painted conductor and the bare conductor, the current carrying, you can see if it is a single run, so it's 160 amps it is taking. Then if you go for the conductor, it's 139 amps only. So the painted surface, why it is taking more current? It's if you go for black matte finish on the surface, the emissivity will be more. So hence current carrying also will increase. So that's why this is increased values has been shown here. So here it is reduced. The bare conductor emissivity will be low. So hence the current carrying also will reduce. So this is the one type of advantage we'll get